Over the last year, a massive shift has taken place in how we build software. Developers are using a practice known as vibe coding, or agentic engineering, where they use plain English to command AI assistants to generate entire applications. But typing a vague idea into a prompt box rarely works on the first try. Giving an AI broad instructions usually triggers the fix, break, fix loop. You tell the agent to correct a button layout, and solving that single issue creates a new bug in 3 connected systems. Because large language models suffer from context loss, this loop rapidly spirals. The AI starts hallucinating functions, and a simple prototype splinters into a fragile mess of disorganized code. Escaping this requires moving the focus away from the act of typing syntax and back toward the discipline of requirements engineering. Success no longer depends on how well you write code, but on how clearly you can define the logic the AI is meant to execute. In this model, documentation is no longer a post-launch summary of what was built. It has become the instructional source that guides the AI's every decision. This is a page from the NASA Software Documentation Standard. Historically, blueprints like this kept human teams aligned on high-stakes projects. Today, that same rigor is applied to AI through spec-driven development, where a product requirements document, or PRD, serves as the primary contract. Instead of a human reading a specification and manually typing out Python or JavaScript, the AI agent uses the PRD as a rigid boundary. It converts your text directly into the logic of the running system. However, even a perfect contract fails if the AI loses track of it mid-session. To prevent the agent from drifting into hallucinations, you need a way to maintain persistent context. Professional workflows use a central file stored in the project folder, often called agents.md, acting as the AI's long-term memory. Before executing any new task, it continually pings this hub to verify project rules, ensuring it never loses sight of the architecture. But even with a perfect memory, AI tools tend to generate generic, cookie-cutter user interfaces. This is where scenario-driven constraints become necessary. Rather than asking for a standard dashboard, you define the specific user flow through if-then behavior triggers. For example, when a user clicks Book Now, show a calendar view. This forces the AI to build for a specific scenario rather than making generic guesses. By combining a rigid PRD, a persistent memory file, and explicit behavior triggers, you replace a vague vibe with a highly controlled construction zone. Managing this construction zone requires documentation that lives alongside the code, a practice known as docs as code. Instead of keeping your plans in a separate Office doc, you save your requirements as a Markdown file inside your version control system, like Git. Storing the spec in Git creates a clear, versioned history. If the AI inevitably drifts off course, a diffable spec allows you to see exactly when and where the instructions were misunderstood, rather than forcing you to reverse engineer thousands of lines of generated code. Keeping the AI on track requires setting hard limits on what it should not touch, called negative scope. Because AI models often add unnecessary features, you must document these boundaries. If team sharing isn't required, a negative scope rule tells the AI to ignore it. These hard exclusions prevent the AI from wasting compute tokens and resources on unasked-for functionality. Using version control to track your intent while deploying strict negative boundaries ensures that the AI builds only what you have authorized. When you lock these pieces together, you replace the chaos of rapid prototyping with the discipline of agentic engineering. In a traditional team, human developers ask clarifying questions about a vague idea. An AI agent, however, will simply follow its own probabilistic path. This shifts the role of the human toward that of a strategic storyteller. Your value is no longer found in your ability to write syntax, but in your ability to translate abstract intent into flawless, rigorous documentation. Spoken English is becoming the primary interface for software, but only when it is used with the same exacting precision previously reserved for code. To build the future of software, the ultimate technical skill is no longer mastering the syntax, it is mastering the document.